This video will be our first video looking at significant figures. Okay, we have two main learning targets that deal with significant figures. Number one, I can identify the sig figs in a measured value, and then also you can utilize significant figures appropriately when you do calculations. So you'll hear me say sig figs instead of significant figures a lot. It's just a way of shortening that phrase. So again, just to give you a context of how to listen to this video and think about it, with significant figures, it's our way of reporting our digits correctly based on the fact that there's error in every measurement we take. So to start out with, you need to learn how to count significant figures so you know what measurements are good and how to really report it. And then you need to learn how to apply significant figures to mathematical calculations. With part of applying it, you need to learn how to round appropriately. Normal rounding rules apply, but with sig figs, everything seems confusing. When it comes to counting how many significant figures there are in any measured number, there are 5 main rules. The way to approach this video is to think of these rules like rules to a game. Okay, if you think about the rules to Monopoly or life, all games you play, chess, right? They're just rules everyone accepts. Like in chess, the little horse guy, which I think is called a knight, moves in an L. There's nothing inherent to the knight that would tell you he moves in an L, but everyone knows the rule, so it doesn't matter. No one's like, why? Okay, it makes sense. And that's to deal with significant figure rules. I can tell you the why behind them, and they might make a little bit of sense, but for the most part, you just have to accept that these are the rules. Memorize the rules of the game, and you'll be able to play chemistry in terms of reporting your numbers. So the first rule in terms of identifying, is this number significant or not, is that any non-zero digit is considered significant. Okay, again, what does significant mean? Significant means it's measured, that someone went into a laboratory and reported that digit based on what their measurement tool was. So if they get a non-zero, it's considered significant or measured. The zeros are what the rest of these rules are going to be about. Okay, we have different cases of where the zeros are and how to use them. If you have a zero between two measured numbers, those are significant because those are measured quantities. In this number right here, 4,005, we know that it's not like 4,205. That zero is a zero for sure. It's 4,005. We don't know whether it's 4,005.1. Okay, that digit's not reported to us, but we know that it's that there's a zero in the hundreds and a zero in the tens. So those are considered measured quantities even though they're zeros. Okay, because you measured them as they don't have any value at this location. The next zero we look at are the zeros when you have a decimal, so a number smaller than 1. And when you have a number smaller than 1, all of the zeros leading up to your first measured digit are not significant. So in this case, those zeros in front of the 8 are not measured quantities. Yes, technically you have a zero in the tenths, a zero in the hundredths, a zero in the thousandths, but they don't affect your quantity. Your quantity starts out at that 8 all the way down at the end. So those zeros are considered non-measured zeros and not significant in that case. So in this case, the 8 and the 1 are the only things that are significant. We have the zeros at the end of a number when you see a decimal point. Okay, so these next two are both going to be about the same rule. When you have zeros at the end of a number and you see a decimal point, all of those zeros are measured and count. So in this example, that 44.0100, all of those zeros count, and this number has 6 significant figures that were measured. If you have zeros at the end and you don't see a decimal point, then all of those end zeros are considered non-measured numbers. Okay, in this 35,000, the 3 and the 5 are the only ones that can be reported. The way this number is written, the author is telling you, I don't know what's in the thousands, I don't know what's in the hundreds, I don't know what's in the tens. Those may be something else. This might be 35,900, but my measurement tool did not allow me to measure at that area, so that those zeros are not significant. The deal with these rules is you need to memorize the rules so that you can look at a number and say, how many measured numbers are there? Okay, how many sig figs are there? Because that's how we end up rounding our answers. In chemistry, you never say, Miss Lee, how many digits do you want? Do you want to the hundredths? Do you want to the tenths? Do you want 5 digits? You always know how many digits to report because it's based on the significant figure rules. So if you run down this slide again, that 24.7, that has 3 measured numbers because all the numbers are counted. That 4005, that has 4 significant figures because the 4 and the 5 are digits, they count, and the zeros in the middle also count as measured. The 0.0081, that only has 2 significant figures because all the zeros in front of the 8 don't count. The 44.0100 has 6 significant figures because everything written with a decimal point counts in this case. And then the last case, that 35,000, again, just has 2 significant figures because the zeros don't count. Those 5 rules are the rules to the game. They're the ones that most people memorize. On this screen, I have more simple rules that will be our kind of long-lasting rules that I remind you of most frequently. Okay, first rule is still the same rule as the first page. All non-zero numbers are significant. And then really we have to look at our number and decide, does our number have a decimal point or not? If it has a decimal point, you start at the left of the number and you go down to your first non-zero. From there on out, all of those numbers are significant. If you don't see a decimal point, then just know again, those end zeros are not significant. They're not significant figures, so you're only going to count the digits in front of the trailing zeros. So then I say start on the right, go to your first non-zero, and the rest of them are significant. So I'm just going to run through this screen as examples so you start to see how this is applied. You'll have to apply it for your homework tonight too, and we'll see kind of how it goes in class tomorrow. So for number 1, that 3190, I don't have a decimal point, which means this 0 is not significant. I have 1, 2, 3 sig figs. So someone said, how many sig figs do I have? 3. The next one has a decimal point, which means all of them count. So that is 5 sig figs for number 2. Number 3 is an interesting thing that scientists do. Okay, I look at this, I have a decimal point. And if I have a decimal point and it's this number but bigger than 1, both of these count, and that's 2 sig figs. If instead a scientist writes it like this without the decimal point, they're saying to you, I don't know this one, and it's just 1 sig fig. For number 5, I have a decimal point, but that number is smaller than 1. So I go to my first non-zero, which is the 5, and all of those count. So 5, 4, and 0 are all measured. So that's 3 sig figs. Number 6 then is 4 sig figs. Again, I go to my first non-zero and I count all the rest. 7, I have a decimal point and the number's bigger than 1, which is great. All of those count then, so I have 6 significant figures. For number 8, I have a decimal point less than 1, so 2, 3, 0, 0, 1 all count. That's 5 sig figs. And number 9 is why we love scientific notation. Anything reported in scientific notation is considered significant. So that 5.70, all 3 of those are measured. And you can apply the sig fig rules, right? It's a number bigger than 1 and it's a decimal point, so all of the things written count. It's our way of saying all these trailing zeros and that 10 to the 9 are not significant, that the 1 0 I wrote was measured, and that's how I report it. So sig figs will be the bane of your existence for the duration of your chemistry career. Please know the sooner you memorize these rules and start applying them correctly, the better off you'll do. Get over the fact that you think this is confusing. Get over the fact that you're like, oh, why do I actually know this? You do. Okay, these are the rules of the game. Memorize them and the game will go much better. The last unit of the year this year, you'll still be using sig figs. Go ahead and do the form and have a nice night.